So I was a founding trustee of a small museum in southeast London in Rotherhithe for about 15 years, and it was dedicated to the building of the Thames Tunnel. And that was built during the first part of the 19th century. But it was built by the lesser known father of Isambard Kingdom Brunel, which is Sir Marc Brunel. And whilst the tunnel was not strictly within the city boundaries, the destiny and the influence that Brunel's had on London is profound. So as this is a soiree and it's past 6 p.m, past the watershed, I've decided to make this into an entertaining story, but I still want to respect the immense engineering contribution that defines the Brunels. So just a little bit of history. The family of Brunels lived, well, for a long while, 200 or 300 years, midway between Paris and Rouen, from around the 15th century. And Marc Brunel was born in 1769, and he was originally destined, much with the influence of his father, to be a priest. But at the age of 11, Marc informed his father, Jean Charles, that he had another calling. He wanted to be an engineer. So I would say that engineers also consider that their time on earth bestowing solutions and good judgments also deserves a place in heaven. Anyway, in 1793, he became a naval officer, but at the age of 24, he managed to escape from the turmoil of the French Revolution and went to an exciting prospect at the age of 24 to New York. And he became the chief engineer after 2 years of being in New York, and served as their chief engineer for about 3 years. But love and romance came in the way, and he came back to London in order to marry his wife, Sophia Kingdom, and he joined the United Kingdom Navy Board. From that time, he was solving problems on what we call ship's rigging blocks, and he took out several patents during this time when he was there, including 2 for tunnel boring machines. But he then started, the business side kicked in, he started a bootmaking business for the military because of the Napoleonic Wars, and he saw an opportunity. But due to several poor decision-making and miscalculations, he became bankrupt and he went to a debtor's prison. Anyway, high-ranking friends in 1821 managed to get him out of there, and through the influence of Wellington in 1825, he was appointed by the newly elected government board to build the proposed tunnel underneath the River Thames. And he was then to be supported by his more celebrity son, who was probably became the Bill Gates of his day, but it was part of a very talented family because Isambard Kingdom's Brunel's son, Henry Brunel, also participated in the design of the Tower Bridge. So we're getting closer to the city, or at least on the boundaries anyway. But the legacy of the Brunels definitely is a foundation for London, and certainly what Marc and Isambard Kingdom Brunel built was the foundations of a lot of modern infrastructure we see. So the subject this evening is about the world's first underwater tunnel. And this really does bring out the heroism of engineering, the determination to carry on regardless of floods and other tribulations, using the latest techniques in communications and PR. And even when the tunnel was opened and they couldn't find a proper use for it, they turned it into an underground circus, which I will tell you a little bit later on. But then it evolved into the birth of the metro. It's also a tale about short men and top hats. Brunel often complained that his genes from his family made him into a short man. And sometimes he would catch himself in the mirror and think, yes, I need to put that top hat on to elevate my status a little bit. I don't know whether that's anecdotal or apocryphal, but anyway. So, the Thames Tunnel. The River Thames, as you know, rises up in the Cotswolds and comes out in the estuary into the North Sea, as you can see in the top right-hand side. And the scene that you see in the top left-hand side is a sort of sketch of what London and the River Thames looked like, looking upstream, probably from around about where Tower Bridge is now. And in the bottom right-hand side, 300 years later, or 200 years later, we see what the modern vista is, looking in an upstream direction. The location of the Thames Tunnel, if you look in the bottom left-hand side, is located by that yellow box and the cross. So probably about half a mile downstream from Butler's Wharf. Incidentally, that is the site of one of the tideway tunnels being built at the moment as well. Now, the River Thames, well, 50,000 years ago, it didn't exist, or certainly in the form it was now. And of course, England and what is now UK was physically joined to the main body of the continent. So you could say that 50,000 years ago, UK was definitely a part of Europe, whether you're a Remainer or whether you're a Leaver. But geological events always said that we were always going to leave. So here's some scenes from London in the 17th century and the 18th century. And the top right-hand side shows the famous picture of the Thames that froze over during the 17th century. But the growth of London and its importance around the world, mainly because of the strength of the Navy, made London a very important port. And the Pool of London in the 1700s and the 1800s was where the world's trade came up the Thames, and there could have been 3,000 tall-masted ships in the river everywhere, every day. But the problem is when the ships came up the river and wanted to offload their cargoes, they couldn't necessarily just guarantee the side of the river that they would dock on. And sometimes the boats would have to dock on the opposite side of the river than where the goods were going to be needed. So there was a lot of cross-river traffic to deal with as well. So it was a crowded place, and something needed to be done about getting from one side of the river to the other, because all London had at that time was the Old London Bridge, which I'll talk a little bit about in a minute. Another influence, apart from wanting to get across the river to serve the trade in London, was the Napoleonic Wars. And Wellington wanted to ensure that he could get troops down from the north of England and northern barracks to Woolwich. So Wellington was a great advocate for this venture of building the tunnel. So I referred earlier on to London Bridge, and that was the only way to cross London. Certainly, well, that was it. That was the most easterly place to cross the river. And the city decided that something needed to be done. And the only way you could do that and still accommodate the high-masted ships that were coming up the river was to build a tunnel underneath the River Thames, which had never been done before. And so here come the Brunels. Marc Brunel was appointed to come up with a solution for getting underneath the River Thames. And if you can follow my cursor, the location, as I indicated earlier on, what the intention was to be able to sink two shafts on the north and the south side of the river, build the tunnel, and then have circular ramps which would allow horse-drawn carriages to then get down to the lower level in order that they could traverse underneath the river. So a big challenge, and never been done before. Now, whilst Marc Brunel was working for the Navy Board in Portsmouth, and he did some work also in Chatham, he noticed when he was doing his studies on the ship blocks, so indicated here on the top right-hand side, he was very much aware of the shipworm, or Teredo navalis, the terror of the boats. And he noticed that the shipworm was probably about 60 centimetres in length, typically. It would bore a hole into the ship's timbers with its head, and it would secrete all the excavated or eaten wooden material through the rear of its body and secrete that against the side of the holes that it bore. Ladies and gentlemen, I introduced the term innovation because everything that's dressed up as innovation nowadays does not compare with translating a good idea from Mother Nature and translating it into the birth of something incredibly useful for tunnelling. So Marc Brunel was charged with building the tunnel, And the specification was this: cross under the river. It had to be large enough for horse-drawn carriages to pass. There was a low cover to the tunnel because obviously if you went too deep, that would put up the cost. So you were going to have to traverse the soft ground of the Mother Earth underneath the River Thames, very close to the riverbed. The Thames at that time was a sewer, and the toxic gases which emanated from the river were potent, and that was a challenge that Brunel would have to meet. Never been done before. As we all know, engineers who have to build infrastructure, the investors said we had a tight budget, and of course they wanted it done as soon as possible. Nothing ever changes. Now, in order to sell his techniques and show to the shareholders and to the public at large that this could be done, Brunel drew on his patents that he came up with for tunnelling. And in order to convince people that this could be done, he had to come up with the high quality of draftsmanship in order to demonstrate to people the methodology that he would use in order to convince the funders and everybody that it was safe and it could be done. And literally, he had to use the PowerPoint of the 19th century, which was good drafting with colour wash in order to provide a convincing picture. And I'm going to show you a close-up now. This is taken from prints that the museum that I was a trustee of, we, through a lottery funding, were able to obtain the original prints at a princely sum of £250,000 about 3 years ago. The quality is incredible. The close-up shows the labourers' whiskers, the shadows reflected on the side of the machine. The casing for the pistons are shown in a way that you could see that they were circular. Everything about this picture, well, most engineers would absolutely give their right arm for a picture like this. I mean, it truly is magnificent draftsmanship. And this is what Brunel used. Now, in the end, he realized that the patents that he'd taken out were for what I would call smaller diameter tunnels. The specification called for openings in the tunnels to be able to take horse and carriage. And he couldn't, through the technology that was available at the time, so there was cast iron, there was hydraulics, but he couldn't scale it up to the size of the cross-section that was needed for the tunnels. So in the end, he elected to construct what in effect was a brick box with two holes in it. But the way he did that was adapt his ideas from the tunnel boring machine patterns that I've just described. So what he came up with was a shield which consisted of many compartments with a labourer that would be in each of those compartments. And the labourer would then excavate the ground within that compartment, and then with jacks would then support with timbers the tunnel face in each of those compartments and progressed the width of a brick. And then having progressed for a width of a brick, the jacks would then push against the already built brick box. And when the jacks were withdrawn, then the bricklayers could then lay the extra brick arch and then move forward incrementally like that. A lot of principles for modern day tunnelling are based on this basic technique. So that was the birth of the tunnel boring machine. This is the legacy of the Brunels. When you compare the size of that shield that Marc Brunel designed and had working in the tunnel, it was about 6.8 meters in height. Very recently in Seattle, the American engineers built a tunnel 57 feet in diameter. A lot of the principles are based on a patent taken out in 1818 by Marc Brunel. So it really is the birth of modern day tunnelling. Now, the construction started in 1825 and it went on till just before 1843. And there were lots of tribulations along the way. There were 5 tunnel floods. He had to replace the shield because of a cave-in. They had funding problems. There was a wages strike. Marc suffered a paralytic stroke, and no wonder, because of all the tribulations that he suffered. Isambard, his son, nearly drowned in one of the major inundations that happened. Unfortunately, there were 6 fatalities in one of those inundations, and there were frequent explosions due to the toxic gases that seeped in from the river. Because you have to understand that the Thames at that time was an open sewer, and explosions would occur because in order to get light into the tunnel, the miners were using paraffin lamps. So it was a sort of hotbed of today's health and safety executive would have had a fit. On one of the occasions, just to show how determined Marc and Isambard were to carry on, they had to inspect the riverbed. So when they had the cave-in, they located where the cave-in had happened. They put down sandbags and clay into the area where the tunnel had collapsed. And then, in order to ensure that the tunnel had been sealed and no more earth was coming through or water, Brunel was taken in the inundated tunnel, walked over the spoil that had seeped in through the tunnel face, and went personally to inspect whether there was any gaps at the front of the tunnel. And during one of the inundations, he was actually carried away something like 500 feet from where the cave-in had happened, all the way to the bottom of the shaft, and then up the shaft as the water rose, and had to be rescued and almost drowned. So, an heroic attempt. And the fundraising that I talked about earlier on was probably a masterpiece of PR, which modern day PR companies would have given their right arm in order to use. In order to gain confidence and raise awareness, Brunel organised a dinner underground with a military brass band and invited all the influential people from government and funders and served a magnificent dinner underground. And Queen Victoria came to tea one day just before the opening of the tunnel. She'd heard with curiosity that there'd been a lot of interest in the building of the tunnel, and she came along for an afternoon visit. So the tunnel opened in 1843, but they weren't able to fund the approaches to the tunnel. You know, I talked about a spiral approach. They couldn't afford to do that. So any coach and horses had to be actually lowered down the shaft and then just continually go through one tunnel and then come back through the other tunnel. When it opened, the tunnel was visited in the first 3 months by 1 million people. That was half the population of London. That was the level of curiosity when you paid your pennies in order to come and see what the Victorian press said at the time was the 8th wonder of the world. And in addition to being able to allow pedestrians or possibly military to be able to get from one side of the river to the other, they started to be entrepreneurial and thought about having circus shows. And there were shopping facilities in all the arches that were underneath the tunnel. And as time went on and the curiosity died away, it became a place where ladies of the night would sell their trade. So what to do with this, what became a white elephant? Well, all those years later, in 1869, it was turned into a railway tunnel with crossing between Rotherhithe and Wapping to serve the growing commuter traffic that was coming into London. Unfortunately, at that time, they had to use steam engines. So the shafts obviously became very useful for the ventilation of the shafts, but it wouldn't have been a very pleasant journey for anybody who'd been inside any of the carriages. But what we do have, and I put a picture of the Crossrail tunnel there, what we do have is, through this method of excavation, boring the tunnels, as opposed to the early tunnels that were built for the central and district line within London, they were built by open cut. What you have is the foundation of what has become the principal method of boring tunnels within city centres, and these highly sophisticated tunnelling machines. Now, the museum that the trustee of, is located on the south bank of the river at Rotherhithe, about 300 yards walk north of the Rotherhithe station. And the museum's visited by the public and also by engineers, and on many occasions I've hosted visits by the American Society of Civil Engineers and also the Norwegian. We even had the Norwegian ambassador visit just after Christmas, just before lockdown. But the top of the shafts, during the construction of the East London line, which is where the Rotherhithe to Wapping tunnel goes, Balfour Beatty, the contractor, offered to put a capping concrete floor about 15 meters below the surface, and we converted that into a public space with a staircase, so that events can be held down there. You can have pop-up opera, you can have cocktail parties, or you can have presentations around engineering, and it's become a go-to place. And every Friday and Saturday night and Sunday night, on top of the shaft, where there's another concrete slab, there's a converted garden, what we call I can't pronounce the name of it, but anyway, it's a garden which has many types of flowers, and it's turned into a cocktail bar. So what we get is a younger generation coming by thinking we're going to a quirky place for entertainment, and actually discover there's a museum. So the museum stays open until about 10 o'clock at night, and providing people are sober, they're escorted around and shown the wonders and the marvels created by the Brunels. So this is what it looks like when we've got entertainment down there. And on the left-hand side, you can see in chronological order the Mayflower sailed from about 400 yards from where the shaft is on the Rotherhithe side. The Mayflower was constructed in Harwich, came down to Rotherhithe to pick up paying passengers before it then went on to Plymouth to pick up the rest of the pilgrims in order to go out to the new territories. And there's a pub there which is older than the Mayflower, which is called the Mayflower. In 1973, the trustees took charge of the museum, the engine house where the pumping water took place, and decided to look at plans where they could make a better gesture to celebrate what had been constructed all those years ago. It's open to the public. You can hire the top half. I hired it for my 70th birthday party. My wife made me a tunnel boring machine cake, which you can see here on the left-hand side. I actually showed it to the chairman of the manufacturing company, and he ordered 3. We have plans to be able to join the top of the shaft with the engine house so that we can create a sort of an experience so that people can understand how tunnelling came about, how it has influenced the world of underground metros and helped to build thriving metropolises such as London. So there we have it, ladies and gentlemen, a testimony to innovation and determination, and what a fantastic legacy. And the curious and the determined come along to visit it. It's a shame that the museum is closed at the moment. It's suffering financially. But let me just say one more thing. The address of the museum is at the junction of Brunel Road, Tunnel Street, Railway Avenue. What civil engineer wouldn't want to have an address like that? You wouldn't even need a postcode. Ladies and gentlemen, thank you very much.